Hello Year 7, welcome to Lesson 5 of the Speed and Forces topic. Today's title is Pressure. Make sure this and today's date are written at the top of your page. So, these two objects are the same mass, but one will go through butter, but the other would lay on the top. Why? Why would the knife go through the butter, but the book would sit on the top if they have the same mass? It's all to do with pressure, and we are going to look at pressure today. So first of all, what is pressure? Why would a lady in high heels standing on your foot hurt more than an elephant standing on your foot? It's because the elephant has a larger weight than the lady, but the contact area between its feet and the floor is much larger, so that force is spread out. Pressure is how much something is pushing on something else. It is related to force and the area that force is applied to. If a force is applied to a large area, the pressure will be. If a force is applied to a area, the pressure will be greater. To reduce pressure, we can the surface area. Pause the video and see if you can fill in the blanks. So the first word was lower, the second word was small, and the third word was increase. High pressure versus low pressure. A force spread over a large area produces a lower pressure. Which type of footwear would be better for standing on a muddy field? The flat-soled shoes or the high-heeled boots? The shoes that have flat soles spread the person's weight over a large surface area. These boots exert a low pressure on the ground. In contrast, the soles of the high-heeled boots have a smaller surface area and so exert a higher pressure. These shoes are likely to sink into soft ground. Have a look at these different examples of objects that take advantage of pressure. Which ones want low pressure and which ones want high pressure? See if you can work out why. Okay, so the snowshoes have a large surface area to help reduce the pressure. They need a low pressure to stop the person sinking into the ground, into the snow. The camel's feet work in a similar way. The area of their feet is quite large, so that there is a lower pressure stopping them to sink in the sand. The hypodermic syringe that you might have an injection with has a very low surface area, so it has a high pressure, and this makes it much easier to puncture your skin. The sharp knife has high pressure, it is very skinny and that surface area is really small so that it can cut through the tomato. The bed of nails uses a low pressure. Your body weight is spread across all of the nails so that it doesn't puncture your skin. And comfy chairs also have a large surface area to help support you, and it puts less pressure on your body parts. We can calculate pressure. Pressure is the force per unit area and is calculated using this formula. Pressure equals force divided by area. This can also be represented in a formula triangle. Pressure is measured in newtons per square metre, which are also called pascals. Pressure can also be measured in newtons per square centimetre. We can draw a diagram to represent the formula for pressure. So we have force measured in newtons, pressure measured in newtons per metre squared or newtons per centimetre squared, and we have area, which is also measured in metres squared or centimetres squared. These are the three equations you can get from this triangle. So force equals pressure times area, pressure equals force divided by area, or area equals force divided by pressure. Calculating pressure. Things that we need to look out for in questions. Do we need to calculate the area, or has it already been done for us? So if we were given this rectangle and it just had the lengths of the sides, we would have to calculate the area by timesing them together. Do we need to calculate the newtons or the force, which is measured in newtons? So for these dumbbells, we're told the mass is 25 kilograms. So we need to work out how much they weigh. And we do that by timesing it by the Earth's gravitational field strength to get the weight in newtons. Let's have a go at this question. A box creates a force of 100 newtons on a table. Its pressure on the table is 15 newtons per metre squared. Find the area of the base of the box is the first step. So we need to find out the area. So we're going to do force divided by pressure, and I've circled the two numbers that we're going to need to use. So we're going to do area equals force divided by pressure. The force is 100 newtons and the pressure is 15 newtons per metre squared. So our area is 6.67 metres squared, and it's metres squared because our pressure was in newtons per metre squared. Question 2. An elephant's foot has a pressure of 10,000 newtons per metre squared. The area of 1 foot is 0.18 metres squared. Find the force of 1 foot. So, circle our values that we're going to use. The force equals the pressure times by the area. So we need to do 10,000 times by 0.18 to get 1800. Can you work out what the units will be? It's newtons, because it's a force. Next question. A weight is placed on a table. It has a mass of 25 kilograms. The dimensions of the face on the table are 5 centimetres by 5 centimetres. Find the pressure of the weight on the table. Now, we don't have the force, but we have the mass, so we can calculate the force. We also don't have the area, but we have the lengths, so we can calculate that as well. So, to calculate the area, we do 5 times by 5 to get 25 centimetres squared. To get the force, we do the mass times by the Earth's gravitational field strength, so 25 times 10 to get 250 newtons. Now that we have both the force and the area, we can do pressure equals force divided by area. So we're going to do 250 newtons divided by 25 centimetres squared. And that gets us 10. But what units will it be this time? Is it going to be newtons per metre squared or newtons per centimetre squared? This time it's newtons per centimetre squared because we measured our area in centimetres squared. There is an attached worksheet on the Padlet. If you are struggling, please message your teacher and they will be able to send you a more supported worksheet. Have a good day, Year 7.